students. Before we start our topic this morning, I would like to introduce to you first the lesson objectives. First, identify if the problem is a permutation or a combination. Second, differentiate permutation from combination. And the third one is appreciate the importance of differentiating permutation from combination in real life. Now, let's have fun. In this activity, it presents you 4 pictures and then tasks you with guessing what specific word fits the theme of the photos presented. Are you ready? Let's start. Your time starts now. The correct answer is problem. Congratulations to those who got the correct answer. Number 2. Your time starts now. The correct answer is formula. Congratulations to those who got the correct answer. The last but not the least. What is the correct answer? Your time starts now. The correct answer is solution. Congratulations to those who got the correct answer. Thank you so much, class, for your cooperation. I hope you had fun. Class, our topic for today is permutation and combination. But before that, I would like to introduce to you first some important terminologies. Permutations refer to the different possible arrangements of a set of objects. Is an arrangement of all or part of a set of objects where order is important. In symbols, the permutation of n objects taken R at a time is denoted by P of n and R. It can be expressed also using the notations P of n and R and n P R. The permutation of n objects taken R at a time is permutation equals n factorial over n minus r factorial, where n is greater than or equal to r. Combinations, a way of selecting R objects out of n objects where arrangement is not important. The set of different combinations formed from n objects taken R at a time is subset of the set of permutations. The combination of n objects taken R at a time is combination equals n factorial over n minus r factorial times r factorial, where r is less than or equal to n but greater than or equal to 0. The difference between combinations and permutations is ordering. With permutations, we care about the order of the elements, whereas with combinations, we don't. Now, let us study some examples. For each situation, tell whether arrangement is important or not. Example number 1. Choosing 3 members from 20 students who will represent the class in math, science, and English contests respectively. To represent class in math, science, and English contests, 3 students out of 20 will be chosen. After 3 students are chosen, they will be assigned to the contests they will join. Thus, arrangement is important. The first example involves permutation. Example number 2. Choosing 3 teachers from 6 teachers in mathematics who will teach 3 sections in grade 10. After 3 mathematics teachers are chosen, they will be assigned to the 3 sections in grade 10. Thus, arrangement is important. The second example involves permutation. Example number 3. Selecting 4 pizza toppings from 9 toppings suggested in the menu. The order of the pizza toppings is not important as all toppings will be placed on the pizza crust. Thus, arrangement is not important. The third example involves combination. Example number 4. Selecting 10 questions to answer out of 15 questions in a test. The order of 10 questions to answer out of 15 questions is not important. Thus, fourth example involves combination. And now, I would like to present more examples of permutations and combinations. Permutation involves arranging books in a shelf, forming different numbers from 5 given digits, forming plate numbers of vehicles. And for combination, we have selecting 4 from 8 available fruits in making fruit salad, choosing 15 out of 45 students to join the school's dance club, and choosing 2 literature books to buy from a variety of choices. Class, this time I will give you an example of a permutation problem. In how many ways can 5 people arrange themselves for picture taking? To solve the problem, first, we need to identify the values of n and r. N equals 5 and r equals 5. Next, substitute the values of n and r to the given formula. So we have the permutation of 5 objects taken 5 at a time is equivalent to 5 factorial over 5 minus 5 factorial. Then, we need to simplify. 5 factorial is equivalent to 5 times 4 times 3 times 2 times 1. And that is equivalent to 120. Thus, there are 120 possible pictures. This time is a combination problem. In how many ways can a committee of 4 members be formed from 8 people? To solve the problem, we need to identify first the values of n and r. N equals 8 and r equals 4. Next, substitute the values of n and r to the given formula. So we have the combination of 8 objects taken 4 at a time equals 8 factorial over 8 minus 4 factorial times 4 factorial. 8 minus 4 factorial equals 4 factorial. 8 factorial is equivalent to 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over 4 factorial is equivalent to 4 times 3 times 2 times 1, then multiplied by 4 factorial, which is again equivalent to 4 times 3 times 2 times 1. Lastly, we need to simplify. So we have 7 times 2 times 5, which is equivalent to 70. Thus, there are 70 ways. Class, do you have any clarifications? Now, let us have your assessment. This is to check whether you really understand the difference between permutation and combination. Study the following situations. Identify which situations illustrate permutation and which illustrate combination. Number 1. 7 people posing for pictures. Number 2. Choosing 5 of your friends to attend your birthday party. Number 3. Picking 6 balls from a basket of 12 balls. Number 4. Assembling a jigsaw puzzle. Number 5. Choosing 8 questions out of 10 questions in a test. Number 6. Winning in a contest. Number 7. Listing the elements of a subset of a given test. Number 8. Assigning seats to guests at dinner. Number 9. Opening a combination lock. And lastly, forming a committee of 6 members from 20 people. Now, let us check your work. Number 1. Permutation. Number 2. Combination. Number 3. Combination. Number 4. Permutation. And number 5. Combination. Number 6. Permutation. Number 7. Combination. Number 8. Permutation. Number 9. Permutation. And number 10. Combination. Congratulations, class, for a job well done! And for your assignment, formulate and solve 2 problems involving permutation and combination concepts in the situation. I would like to end our session with this quote. It doesn't matter what your probability of failure is. If there's a 90% chance of failure, then there's still 10% chance of changing the world. Thank you so much everyone for listening. That would be all for today. Please be safe. Goodbye.